Milling machines are machine tools used to remove material from a workpiece, giving it precise shapes and dimensions using a rotating tool called a milling cutter. Milling makes it possible to create flat surfaces, grooves, shoulders, slots, gears, and complex profiles on different materials such as metal, wood, and plastics. A milling machine is made up of several main parts. The base is the supporting structure of the machine, on which all other components are mounted. The work table is a movable table where the workpiece is fixed using clamps or fastening brackets. The spindle is the rotating axis on which the milling cutter is mounted. It is responsible for the rotary motion of the tool. The spindle head supports the spindle and allows for adjustments in height and angle. The slides allow the work table to move in longitudinal, transverse, and vertical directions to position the workpiece relative to the milling cutter. The motor provides the power needed to rotate the milling cutter and move the work table. Finally, a lubrication system is used to supply coolant to the tool, helping to cool it down and improve the quality of the surface finish. Milling machines are used for four main purposes: to create flat and angular surfaces with high precision, to cut grooves, slots, and shoulders, to shape complex profiles on three-dimensional pieces, and to machine gears, cams, and precision mechanical components. The milling machine works through two main movements, the cutting motion and the feed motion. The cutting motion is the rotation of the milling cutter, which removes chips from the workpiece. The cutting speed depends on the type of material being processed and the geometry of the tool. The feed motion is the linear movement of the workpiece relative to the milling cutter. It can move in three directions: longitudinal, transverse, and vertical, depending on the type of work required. The combination of these movements allows the desired shape to be obtained with high precision. There are different types of milling machines, each designed for specific tasks. The most common are the horizontal milling machine, the vertical milling machine, the universal milling machine, the special milling machine, and the CNC milling machine. The horizontal milling machine has a horizontally positioned spindle. The milling cutter moves parallel to the work table, making it ideal for flat surfaces and longitudinal grooves. This type of milling machine is very rigid and stable, making it suitable for heavy-duty work. The vertical milling machine has a spindle positioned vertically relative to the work table. This setup allows for flat surfaces, drilling, and complex profile milling. The vertical milling machine is versatile and offers better visibility during the operation. The universal milling machine combines the functions of horizontal and vertical milling machines. Its spindle head can rotate in different directions, allowing complex work on multiple axes. This machine is used for versatile operations and workpieces with special shapes. The special milling machine is designed for specific tasks, such as gear cutting, profiling complex surfaces, keyways, T-slots, helical profiles, and multiple grooves. Finally, the CNC, or Computer Numerical Control Milling Machine, is controlled by a computer, which allows for programming the movements of the milling cutter with high precision and repeatability. This machine is used for mass production of complex components and three-dimensional workpieces. It ensures high production speed and accuracy in details. Milling is a machining process that removes chips using a rotating tool called a milling cutter. This process allows the workpiece to be shaped as desired. It is different from boring, which is used to enlarge an existing hole and improve its dimensional accuracy and surface finish. It is also different from drilling, which involves making a cylindrical hole using a tool called a drill. The chips produced by milling are generally helical or segmented, and their size depends on the type of milling cutter and the processing parameters, such as cutting speed, feed rate, and depth of cut. Milling cutters are the tools used in milling machines to remove material from the workpiece. They are made up of a cutting part and a body on which the cutting edges, called teeth, are fixed. The body of the milling cutter can be cylindrical or conical, depending on the type of machining. The teeth are the cutting edges that remove the chips. They can be straight or helical, allowing for smoother cutting. The cutting edge is the part of the tooth that comes into contact with the workpiece, removing the chips. There's also a gullet, which is the space between the teeth that allows the chips to be evacuated. Milling cutters work by rotating at high speed on the spindle, allowing the teeth to come into contact with the workpiece and gradually remove the excess material. There are different types of milling cutters, each designed for specific tasks. Sharp-tooth milling cutters are used for flat surfaces and finishing work on flat surfaces. Sawtooth milling cutters are suitable for deep cuts and grooves and provide effective chip evacuation. Constant profile milling cutters are preferred for precision work because they maintain a consistent shape along the entire cutting edge. Replaceable blade milling cutters allow worn cutting edges to be replaced without changing the entire tool, reducing maintenance costs. There are also special milling cutters designed for particular tasks, such as complex profiles, gear teeth, or helical grooves.